What we realize is when we have a lot of samples to run, we need to have several lab tech, processing the blood sample. And we'll see the difference between the different people also processing the blood. So it's very important to take that into consideration, that at least you have per batches, the same person doing the same thing, because both of you will not be exactly the same way, the way you pipette and so on. Doesn't mean that it's wrong, it's a false measurement, but you will have a different way of doing it. So maybe at one part of the step of the extraction, you will have a slightly, different way of doing it. So maybe every time you take less sample than someone else, but it's always very consistent in the way you do it. So it's very difficult to define, really accuracy in those kind of samples. You have to be very careful that it's consistency as well as high quality. But the consistency maybe is sometimes even more important than the accuracy when you process, samples. When you go for the detection, now the analysis, using instrument and different type of detection system, then accuracy can be more controlled because it's more at the instrument level.
That accuracy is important, but sometimes you have to be really consistent as well as being accurate, because everyone's accuracy is going to be a little different, but as long as you're consistent in everything you do, then that's pretty accurate in itself.
I've been involved into setting up a conference a few years ago, and it was a conference in atomic force microscopy. So it's a type of instrument that really look at the surfaces, and it's a small tip that can come and scan the surfaces and give you the topography of the surface. But depending on the interaction between that probe and the surface, you can really ultimately image the surface at the atomic level or close to the atomic level. So that was a technology that was developed in the 1980s at IBM in Switzerland, and they got the Nobel Prize for that technology. And during the last 10 years, there was a lot of activities how we use those technology in different applications. So first was material science, the second one was physics, and ultimately biology. So there was a lot of activities. So and typically those two activities were polarized between typically the US. There was a lot of discovery of building those instruments to do those kind of measurements, as well as Switzerland, because the technology was initiated there. So we did an international workshop during which we invited people from Switzerland and people from the US. And it was very interesting because the way people approach problem is slightly different in terms of the culture as well. So the people coming from the US, they were very eager to show their new result and a new application or a new way to build the machine, to do the microscope. But it was always a very quick and dirty type of experiment, proof of concept. Be there first, show it's more exciting, very creative. But they show you a machine that is with glue and rubber band and a small prototype like that. Yeah, you show great result. And then you had the people from Switzerland who were just showing and focusing on one aspect of the technology, but they were digging very deep into it, and they were building prototype for the microscope that was completely polished, like almost a finished product. They put a lot of time and effort to make it nice. It has to be well characterized, very accurate and precise. And it was very interesting to see those two groups, interacting together, because they were trying to achieve the same objective, but coming from different aspects and different approaches, and were very influenced by their culture as well. And precision was one of the elements that was quite different between those two groups. So.